Good afternoon, everyone. I am Jodie. I am an application engineer for VI Grade. Thank you very much for joining me today on this presentation about revolutionizing vehicle development with the VI Grade Virtual Proving Ground. So let's start with the challenges that we face in modern development. The first one is to ensure safety, be it that of test drivers or of end users of the state-of-the-art technologies that are developed every day for driving assistance systems and automotive vehicles, which contribute to the increasing complexity of vehicles along with electrification and ever more performance systems. This complexity needs to be coordinated and managed. The last challenge is one that we're all familiar with, of reducing costs. In order to meet these challenges, there are some needs that need to be met. The first one is that the intersection of safety and complexity is on-track testing, where you need to run on so many different operating conditions, on so many different kind of scenarios to make sure that the products that are being developed are safe for the end users. To manage increased complexity while reducing costs, virtual development is the answer, as it allows you to fasten the development process and reduce the number of parts and prototypes. Finally, at the intersection of safety and reducing cost for test drivers is the need for a realistic context, so high fidelity simulation environment. And at the intersection of all of these needs is the new VI Grade Virtual Proving Ground. This proving ground is compatible with all of our driving simulators, as you will see in this short trailer video to get us started. So this is our DM400 FSS equipped with the HyperDock. This is a DM150 running on a digital twin of a real-life road. And driving on the comfort lane is a compact FSS for full spectrum simulator. So as you have seen, and as you will see, this virtual proving ground presents a number of features and testing scenarios. Please note that all of these are virtual scenarios, and if you're interested in virtual models of existing tracks and proving ground, we can provide those thanks to the help of our partners. This proving ground fully integrates with VI Grade simulation tools for free, and it enables cross-department collaboration and teamwork. But first, as any engineer would do, let's start with the numbers. So this proving ground contains more than 50 kilometers of road, which is 31 miles, if there's any American listening in, that you can drive on between connecting roads and the principal driving areas that are in 13. On these certain driving areas, you can experience a full spectrum of frequencies, all of this in one unique proving ground. So we call this proving ground a full spectrum proving ground because it handles everything from handling, ride, and comfort, all the way up to vibration and all around sound. It integrates fully with the VI grade ecosystem, which is made of simulation software, driving simulator, and hardware in the loop. So let's start with a quick overview of the simulation software. So in order to bring collaboration between teams to the next level, we propose a suite of software that allow teams to collaborate. Our flagship software is VI Car Real Time, which you can see on this short video. It allows to have a high fidelity model that you can run on a number of events and that fully integrates to the virtual proving ground. On the other side of the spectrum, we have VI innovate, which is our software for NVH engineers so that they can design the right sound and experience the behavior in vibration. For HMI engineers, we propose VI WorldSim, which allows to test in safety and immersive environment any HMI design that you might have implemented. And finally, always with VI WorldSim, we handle any need for any ADAS engineer by allowing to create your own driving scenarios, putting in the actors and testing your control logics in all safety as well. So let's talk a bit more in detail about the three softwares that I name-checked just now. The first one is VI Car Real Time. As I mentioned, it's a high-fidelity vehicle model. It's a parametric one that can run in real time. You can conduct a number of design of experiments on the proving ground on all of the driving areas that I will later present to you. And you also have the possibility, thanks to our advanced driver model, VI Driver, of optimizing lap times on the closed circuits area. For what regards NVH, this is a tool for NVH engineers to design their sound on a variety of scenarios and all operating conditions thanks to the proving ground. Sorry about that. Always NVH allows you to build virtual prototype from CIA data or from measurements, and you can also do a combination of both. You can compare your model instantly back to back, and you can interact and modify the sound in real time. Now going on to the next slide. VI WorldSim is our tool for both offline and online use of the proving ground. It's a single high-quality graphic engine running on Unreal 5. It contains all of the basic sensors, such as camera, lidar, radar, and ultrasonic sensors, and you can also have access to the ground truth. You can create any type of scenario from scratch or from predefined NCAP scenarios. And all of the actors are handled by a powerful traffic manager. This software, as I said, can be used either offline, but also online on our driving simulators. The offer starts from the desktop, which is very much engineering oriented and exists in a ride and handling configuration and an NVH configuration. Then our entry-level solution of simulator is a compact simulator, giving you immersive ergonomics and existing in ride and handling configuration, NVH configuration, and FSS configuration. So full spectrum configuration that covers both ride and handling and NVH. To increase the immersivity, we have the static simulator, which can then be upgraded to our dynamic simulators. This one can be further enhanced by adding the HyperDock to experience the full spectrum. Now let's move on to the hardware in the loop capabilities, which can bridge the gap between online and offline simulation. Let me start the video here. Hardware in the loop allows you to test your real-life components on the virtual proving ground, thanks to our partner company Concurrent and their Autok. The Autok has a multi-core technology from 8 cores to 64 of them, and support all automotive communication protocols such as CAN, lean, and FlexRay. And in line with our open approach at VI Grade, everything is accessible through APIs for C language, Java, MATLAB, and Python. That was an overview of what we can do today in VI Grade, but let's now get into the actual proving ground. So you can see the 13 areas I mentioned before that are all explained on the right, but since there's a lot going on, I propose that we embark on a virtual tour together. Starting at our VI Grade Sim Center at Udine, which in this case acts as a connecting hub to the rest of the proving ground, thanks to 4 connecting roads and 2 roundabouts that you can use to simulate somewhat the urban environment. From there, you can reach a high-speed ring. So it's almost 9 kilometers long. It has 4 lanes and a maximum banking angle of 11 degrees. The longest straight is 2.5 kilometers, making it suitable for ADAS and HMI application, where often a straight line is all that is needed for the baseline. At the north of the map, we have the highways. They are 2 kilometers long. They contain 4 lanes, and there are 2 standards that are represented, the European one and the US one. So you can cross test your vehicle for different markets. We can then move on to the comfort lanes that you saw in the video with our compact FSS. They are 2 kilometers long, and there are 6 of them. So we have 2 flat surfaces, 2 alternating types of concrete, a lane of anti-skid patches, and then 2 types of asphalt, coarse and smooth. You can see in the word that we included the name of the lane so that the driver, when immersed, can actually see where they're going. And all of these lanes, as well as the entire proving ground, is compatible with advanced VI NVHC models. So that means that NVH engineers can give their sound model to vehicle dynamics engineer, for instance, so they can have a realistic sound. Below that, we have the ramps. They're 300 meters long. There are 3 of them, and in total, there are 6 different slopes for the ramps. So it starts at 5%. It goes up to 30% at a 5-step interval, 5% step interval. Below that, we have the right lanes, which are great for ride and comfort analysis. They're 300 meters long. There are 9 of them with the speed limits so that you avoid being shaken if you're going too fast. And we have 1 cat size, 2 lanes for cleats, and then 1 lane each for speed bumps, slabs, and the Belgian blocks. And we have then 3 waves with different amplitudes and frequencies. So in total, 6 event categories. Below that, we have the handling track, designed by our engineers at VI Grade, designed to have both high-speed and low-speed curves, 10 of them in total, over 3.2 kilometers length. There are 3 materials, the track asphalt, the curbs, and the grass, and they all have different properties so that when you're driving, you can actually feel the difference. Below that, we have our rally track. It's a little bit shorter at 1.1 kilometers. It contains 9 curves and 5 bumps, and it can be used for any off-road applications that you need. Next up, we have something quite special, the country road. It's special because if everything else has been fully virtual, this country road is based on a real road, and you saw it in the video. So it's a real road in Udine, and it has been scanned with a laser scan over 2.4 kilometers with a 2.5 centimeters resolution. So you can see in the video below, application with a VR headset, which is compatible with the entire range of simulators that we offer at VI Grade. This country road is great for development, for validation, and also for showcasing purposes because it represents the highest that you can do with a digital twin road and high-level graphics that are really representative and immersive. Moving on, we have the open area, which consists of a big rectangular area with circles of different radiuses, 1 skid pad, one skid pad, and then a full unmarked area where you can conduct your handling tests, as well as 5 split mute lanes, of which the coefficient of the friction coefficient you can choose to modify if you so wish. You can also use this area for ADAS and HMI application if you need to go in a straight line. As we near the end of this presentation, let me introduce the wet area, which is composed of 10 circles of alternating friction coefficients, one ring, and then one open area. Finally, we have the ADAS area, which, as you can see now, is a little bit bare. It's still a work in progress. Our development team is hard at work to create an immersive urban environment with functioning traffic lights and implementing the road signs. This will be implemented for 2 mirror areas to accommodate for left driving and right driving. So stay tuned for when this part will be officially released. Thank you for your attention and following along. You can get the VI Grade Proving Ground for free now. You can do so by requesting your demo licenses of our software and arranging your own driving experience at one of our sim centers. We've already seen the one at Udine, Italy, but we also have one in Novi, Michigan. If you're interested, you can write to info@vi-grade.com, or you can scan the QR code that you can see now. Thanks again for your attention. If you have any questions, I will be happy to answer them.